Hello everybody, welcome back to Logs. Time to do some simple solving of logarithms, and actually, you've already done it. Today will be a pretty quick lesson. The better one will be the next one, 7.5 lesson from the book, My Strange and Weird Properties Day. Anyway, the way you first solved a log problem was to rewrite an exponential form. So go ahead and do it for just a sec. Just warm up and see if you remember how to rewrite these in exponential form, and you'll be solving a log problem because it's a log problem. So go ahead and hit pause and try it. Okay, I'm back. Anyway, hopefully you did 2 to the 4th equals x. Okay, fine. So x equals 16. That's easy. And over here you would have done 36 raised to the 3/2 power equals x. And don't forget, a log is a power, therefore I can say it as base. 36 raised to the 3/2 power equals x is what we're doing. Now, how do we do this without a calculator? Because you remember from the quiz, I didn't let you have a calculator for this. So if you remember from exponent properties, this I can do, this is 36 cubed, and then this is the square root of it. So I can do either, it's the power to a power rule. I can choose to do this as 36 to the 1/2 power, and then that cubed, or I can choose to do 36 cubed and that to the 1/2 power. And then hopefully you're going to look at this and say, choose that option. And the square root of 36 is 6, so that's the same as 6 cubed, which in this case, x equals 216. Okay, now that is a good simple way to solve a logarithm when you can map it like that. Mapping is the first way, and one of the preferred ways I have for solving a log. Okay, now you get back to here. I can't map that because it's like 2 to what? This whole thing over here? And then if you remember how when we had, for exponentials, we had like 2 to the x power equals 2 to the 4th. Well then, if the bases match, well then the x must equal 4. Same thing with logs. Log base 2 of this, log base 2 of that, well this must equal that. So we say, okay, fine. X squared minus 4 must equal 5. Therefore, x squared must equal 9. Square root. Be good about it. Don't forget, this is x equals plus or minus 3. And that's a good way to solve. We come over here and we say, okay, fine. It's log base 1/8 on this side, log base 1/8 on that side. Okay, I can handle that. And we say, well, x squared minus 4 equals 3x. Okay, remember, don't forget quadratics. They're always there for us. And then we set that equal to 0. We factor it because we remember how to factor. And that must be x minus 4, x plus 1. And then we say, okie dokie. So I get a 4 out of here and a -1 out of there. And so x must equal -1 and 4, and I circle it and I'm done. Nope. Hold the phone. Remember, can you log a negative? And I'll just, for refresher's sake, remember, always have a visual. Remember what our parent graph looks like. It goes through this, call it the anchor point for a log function of 1, 0. It has a vertical asymptote here because 1/8, there is no power you can raise 1/8 to get you a negative number. So you can't log a negative, and there's an asymptote here. So what about that -1? And you say, nope, can't log a negative. That is extraneous from my solution. I'm going to do an aside off to the side as well. You may ask, and you may be thinking ahead if you're clever and said, remember back when I had, we had like 1/8 to the x power equals 2 to the 3 power. How did we solve that in exponentials? If you remember, we tried to get the bases to be the same, and 1/8 was the same as 2 to the -3rd power, and that equaled 2 to the 3rd. And then you'd say, fine, well, -3x equals 3, so x equals -1. Remember that? What if I had a situation where, can I do this when I have the log base 1/8 of x equal to the log, say base 2 of x? What if I did that? Is there a way to solve this thing and find out somehow convert from this base of 1/8 into a base of 2? How could I convert from one base to another base using logarithms? I'm really trying to what would that be equal to if I converted log base 1/8 of x? If I wanted to write it as base 2, what would I put in here? How would I change the value of this? So the problem solving technique we're really trying to get here is just, well, test values. Let's explore. Instead of just looking for some simple little rule that we'll forget later anyway, let's have our exploration hat on and say, what would we do? We'll call this the left side of the equation. Let's call this the right side of the equation. And say, what if we had a test value that I plugged in? I don't know. What's an easy number for x to plug in to take the log base 1/8 of? No? We could plug in 1/8 if we wanted. On the left side, what would we get? 1/8 to what power is 1/8? Well, that's 1. And then if I plug it in over here, log base 2 of 1/8, 2 to what power will give me 1/8? Well, that's -3. Okay, what could I do to a 1 to get me to a -3? Well, I could subtract 4, or I could divide by -3. I don't know which way. Let's test another value. I don't know, pick maybe 8. What is a log base 1/8 of 8? Well, 1/8 to what power will give me an 8? Oh, that'd be -1. Log base 2 of 8, 2 to what power is 8? Well, that'd be 3. Whatever I do to the blue example, I want to do the same kind of thing to the green example that we just picked out. Now this is just proof by going through some examples, not a rigorous proof, but it looks like in both cases we can divide by 3. So it looks like what we could do is we could rewrite log base 1/8 of x as log base 2 of x divided by 3. And we could do that, and that did work out. I wonder why. That's weird. You can explore those properties on your own. We'll do some more over the next couple of days. We don't need that for today, but it's a good exploration. Okay, inequalities. What if we look at this one? Oh boy, can I just map it like I would? And how should I map this? From whose perspective? This would be 3 to the 5th is, what do I then write? Less than x? Let's try it. 3 to the 5th less than x. Which, if I flip the direction around, it'd be x greater than 3 to the 5th. Does that make sense? Let's think about it. If I think this might be correct, well, what if I put in 3 to the 6th here? What is the log base 3 of 3 to the 6th? Because 3 to the 6th is certainly greater than 3 to the 5th. And the log base 3 of 3 to the 6th would be 6, and 6 is greater than 5. So, okay. Seems to work out easy enough. And then I come back over here. Let's do the same little rule we had. 2 to the 4th greater than x. And notice in both cases, see how the log expression has x and there's a less than pointing? Anyway, the alligator's not eating x. The pointing part's pointing, and it goes the same direction. Anyway, x still has a less than there. The alligator's eating the x, and the alligator's still eating the x over here, so all good. Same as what we're used to. Okay, so x less than 2 to the fourth. Okay, all right, fine. Call it 16, call it 2 to the fourth, no big deal. Is that hunky-dory? And you might say, hold on, what about negatives? Because like -2 is certainly less than um, 2 to the fourth, and that would work in this expression, but I cannot take the log of a negative, so I know x must also be greater than 0. So I really need to say, well, fine, x is less than 2 to the fourth, but it's greater than 0, because I can't take the log of a negative. Okay, and write that down. Actually, I'm going to write that down. Can't log a negative. And okay, let's keep charging through. Let's try this one out. See how this one works. Well, it looks like we're kind of going through the same process we did up here with equals. And now we've got this situation where, best I can think, if the log base 4 of this is greater than the log base 4 of that, well then this must be greater than that. So I'm just going to write x plus 3 greater than 2x plus 1. Okay, a couple ways I could do this. I could either subtract x or 2x and put all the x's on the left side, but I prefer to keep the coefficient of my variable positive, so I'm going to make it, bring the x's over to that side, so that'll be x. And then 3 minus the 1 is 2, and so x is less than 2. And you may say, so, well, I remember this. I got to think about this also still. Can't log a negative. So now what? Which one of these drives it? Well, what value would make this one be negative? This is negative when x would be less than -3, right? And this one would be negative when x is, well, I'll just solve it out to make it, if 2x plus 1 is less than 0, so 2x is less than -1 and x is less than -1/2. Now, which one of these is going to determine which one goes here? And hopefully you can see that, well, x less than -1/2 is more restrictive, because -1 won't work in this. Well, anyway, this is what can't happen, so I'd have to have x greater than -1/2. And greater than -1/2 will complete this. So what I really want to do is kind of pick the bigger. The more restrictive is the better way to say it, because this is what can't happen. I should have written it. This thing is x has to be greater than, x must be greater than -3, and I really would be better if I wrote this as x must be greater than -1/2, and then it's easier to see that I should pick the -1/2 because it's bigger than -3. Okay, well, I kind of talked around that one a little bit, but hopefully you got it. Okay, now there is this, if you remember from exponentials, there's something that happens with these. It's kind of a little bit different because it's, well, let's just try to go through the process. Well, it's a log base 1/2 of x, log base 1/2 of 4, so this should be greater than that. And we say, fine, x must be greater than 4, and you circle your, no, dang it, and you circle your answer and you say, I'm all done. And then I say, nope, you got it all wrong. Hold the phone. No, because test and think. What is a good point that we could plug in? I don't know. Let's pick test 8. Because is 8 greater than 4? Sure it is. What's the log base 1/2 of 8? And is that greater than the log base 1/2 of 4? Well, let's see. 1/2 to what power is 8? I'd have to flip it and then cube it. So that's -3. Is -3 greater than -2? No. So something's weird about this, and I have to think about what's going on. And then we say, I remember there's a rule. If the base is negative, call it less than 1, not negative, if the base is a fraction, if the base is less than 1, flip the direction of the inequality. And the reason we do that, if you remember, a log is a power, and I could rewrite the power of 1/2 as 2 to the -1 power. So effectively, a fractional base is really introducing this negative that flips the direction of the inequality around. So, and then, of course, so this then becomes x, stupid thing, x is less than 4. And that's my gold star answer. Okay, hopefully that's good enough. See you guys later.